Okay. So if we go back to the previous graph or previous page, right? Moment about y, right? Moment about y is going to generate a what? A compression on element A. When that is the case, you just put a what? A minus sign. Okay, done. Because you finish your analysis already. So when you put your positive and negative, it's so much more what? Straightforward. The next one, we are going to use mx over ixx multiplied by y. Okay, I can't remember what is our mx value. So our mx value is 22.75 times 10 to the power 3. 22.75 times 10 to the power 3. Divide by ixx. We know ixx is equal to 40.8 times 10 to the power minus 6. And then the y value, we know that is 102.5 times 10 to the power minus 3. Okay. Then you look at mx, whether is it positive or negative. Hey, is it mx? Yeah. Mx, right? And at element A, okay, so element A over here, element A is positive. So you put down here positive. Finally, you calculate everything. Minus 18.797. I'm going to do it again. Right, then minus 960. 8.504 or 505. Hey, I beg your pardon. 8.505. I'll do it again. 8.505 and then plus 57.154 times 10 to the power 6. Let me do it again. $57,1754. So 18 minus 18.797 plus by 8.505. Hey, minus 18.797 minus 8.505 plus by 57.154 is 29.852 times 10 to the power 6 Pascal. This is the normal stress. Let me do it again. Wait. $29.8, positive 29 point what? Are we clear? What I just showed you is the procedure how to what? Organize your information. Okay, I know the solution manual just give you one line. Okay, that one line is a very risky line. We clear? Okay, so because it's in 3D, okay, you can get lost. And we're not done yet. We still have what? Shearing stress. Okay, we're not even there yet. Now we are going to focus on normal stress. The next thing we are going to do is we're going to consider element B. And element B, stress Z, or element B, we know the normal stress is the same, yes or no? Right, normal stress is the same. So we're going to put minus 18.797 times 10 to the power 6. Okay, then we look at moment in the Y. So moment in the Y we know is 9700 divided by what? 9.03 times 10 to the power minus 6. So now we are looking at point B. The X distance changes to 3.62 times 10 to the power minus 3. Okay. So now again, we go back to our analysis to look at element and to look at moment about Y. Okay, so if we look at moment about Y, okay, moment about Y, element B is what? Positive. Okay, so if to confirm moment about Y, right? Moment about Y, B is on this side, it is positive. So you put down here, okay, we know it's positive. And then the next one, we have what? We have our moment about X, which is 22.75 times 10 to the power 3, divide by 40.8 times 10 to the power minus 6. Now, over here, your Y value is equal to what? 0. Plus minus 0 is 0. Okay, so when that's the case, you can drop this term out. Okay, because this is 0. So finally, we get minus 18.797 times 10 to the power 6 plus by 900, no, 9600 times by 3.62 power minus 3 divided by 9.03 power minus 6 is equal to 3.848 or 3.849 times 10 to the power 6. Let me do it again. 3.849. Okay, so this will be equal to minus 18.797 plus by 3.849 is equal to minus 14.984 times 10 to the power 6 Pascal. Okay, let me do it again. Yep, 14.948 times 10 to the power. Organizing data, organizing your analysis issue. Company usually use finite element. No, finite element too expensive. One software $60,000 per year. Just for nothing. Are we clear? Okay. As I say, if you look at the textbook, you look at your homework, this is the worst case that you will get. You cannot get any more worse case. Are we clear? Okay, yeah. Hey? Yeah, shear stress. So after term test 2, I need 3 weeks of shear stress. Then we are going to combine everything in most of them. Okay? But most of it is easy. So where we are now in terms of design, where we are now. So if we were to draw element A, right? If we were to draw, I'm going to sketch for you, okay? Oh, don't worry. Shear stress is my specialty. A lot of university avoid it, but we do it, okay? So if we look at element A, so element A is drawn in this direction. Jawohl? Yeah. So this is your element A. Right? This is your element A. And then we have another orientation. This is your element B. So what we have just found out is element A, we have a tensile value of what? 29.852 megapascal. Whereas on element B, we experience a compression of 14.948 megapascal. Okay. Now you all know what your external load. Right. Another question that I would like to address, okay, and this is for confidence building. And I think it's important. And the question I like to address, the question that I like to address, where is it? Homework. Oh, not this one. Ooh. Yeah. The question I have to address is this question over here. Okay, I'd like to address this question. Oh, look at it. Beautiful question. Okay. So the way they address this question over here, now the solution equation on 3D mole circle is they envision how the mole circle look like. But you don't need those equations at all. You don't need. Now, let's look at this problem now. Okay. Now over here, we have to know what are the reactions. Yes or no? Okay. We have to know what are the reactions. Knowing the reactions are critical. Okay. So we are aware, right? Over here, I'm going to call my transformation differently now. I'm going to address my transformation in this orientation, where this is my X and this is my Y. I'm going to do something different. Okay. So now the next thing is we have to know is what? Reaction. Okay. We have to know its reaction. So by looking at here, we know that we have applied force in this orientation, and this is equal to 9 times 10 to the power 3, and we know that this is 30 degrees and cos 30. Okay, so immediately we can compute this out. So 9 power 3 times by cos 30 is equal to 7.7 is equal to, I get 7.794, 7.794 times 10 to the power 3. And then over here, we get 9 times 10 to the power 3 sine 30. Okay, so 9 power 3 times by sine 30 is equal to 4.5. 9 power 3 times by sine 30 is equal to 4.5 times 10 to the power 3 Newton. Okay. Now at point A, how many reaction force? 1 or 2? 1. There's only one reaction force, and the reaction force is in which direction? And this we call our what? AY. Now, how about D? D has 2 reaction force. In the Y direction, and you also don't allow it to move in the X direction. Now, question for all of you, BX, which direction? Going upwards or pointing downwards? Why? Yeah, right. It's pointing upwards, but why? Yeah, to oppose the 7.794 times 10 to the power 3 Newton. Apply no Newton's third law. Action equal reaction, same in magnitude, different in what? Direction. Right? And this is your BX. How about BY? Up or down? Hallelujah. Okay. So what he just did is he just envisioned what? Moment. What do I mean he envisioned moment? So if we remove this support, this force will generate a what? A moment right? The 4.5 will generate a moment going this way, yes or no? So you need a what? You need a counter moment over here. When you have a counter moment, this is where you have your what? Dy. Are we clear? You have to have confidence in drawing your what? Free body diagram. Only when you have confidence sketching your free body diagram, then when a problem like this comes up, you say, easy, slimy and lightly. Slimy. Whatever. Okay? I'll see you guys on Friday then.